कज़न का फ्लैट से ये व्यू आता है, सामने लेक व्यू है, अच्छा लगता है और बैंगलोर सिटी। यहाँ पे बादल ऐसे ही रहते हैं हमेशा, थोड़ी थोड़ी रेन होती ही रहती है शाम को लगभग, इस वजह से यहाँ का मौसम भी हमेशा अच्छा रहता है। हम लोग अभी लाल बाग बोटानिकल गार्डन बैंगलोर में आए हैं। एंट्रेंस है ये, देखिए इतना अच्छा बनाया है। $100-year-old Christmas tree. शीशे का बना हुआ है, पूरा 1989 में बना था।
वो किसका स्टैचू नीचे?
किसका रूम है?
टब। अभी हम लोग यहाँ गार्डन से निकल के जा रहे हैं अपने कजन से। विधानसभा ऑफ बेंगलुरु कर्नाटका।
During the 15th century here in India, Nilakantha Somayaji, a renowned astronomer and mathematician from Kerala, came up with a different model in which 5 of the planets known in his time revolved around the sun, and the whole system revolved around the Earth. Then came Nicolaus Copernicus. He changed what had not been challenged for about 14 centuries. He made the sun the center of revolution. In this model, planets, including the Earth, moved in circular orbits. Copernicus created an ordered geometric universe that accounted for most of the observed planetary motions. A mathematically gifted Johannes Kepler wrote the next chapter in describing planetary motion. Working on precise measurements of planetary positions made by his mentor Tycho Brahe, Kepler clearly demonstrated that planets actually moved in elliptical orbits. Kepler also established a precise mathematical relation between the period of revolution of a planet and its distance from the sun. He even imagined physical forces from the sun driving the planets in their orbits. The exact nature of the force came to be understood some half a century later through a piece of ingenious work, this time by Isaac Newton. A young Newton thought deeply. What pull could hold the moon in its path? Does the force that causes an apple to fall here on Earth extend all the way to the orbit of the moon, causing it to revolve around the Earth? These were brilliant, bold, and courageous questions for his time. Newton went on to show that the force really existed in nature and that it diminished with distance. The force came to be known as gravitational force. Significantly, Newton demonstrated that Kepler's laws of planetary motion were a natural consequence of his newly discovered law of gravity. Here was one universal law that described bodies falling on the surface of the Earth, the motion of our moon, the planets and their satellites, comets, and several others. The long-standing geometric universe of the ancients was replaced by Newton's mechanical clockwork universe. Newton successfully applied his newfound law to solve all the major astronomical problems of his time. One long-standing problem that baffled even great minds concerned ocean tides. It is the periodic rise and fall in the levels of large water bodies, peaking 2 times a day. This effect is mostly due to the gravitational force of the moon on the Earth. Termed as tidal force, it is strong enough to raise ocean levels into a bulge and move it around the globe as the moon goes around the Earth. The sun's contribution to ocean tide is smaller than that of the moon's. The tidal interaction between a planet and its satellite is not at all uncommon. The tidal force of planet Jupiter on its satellite Io is so severe that Io's landmass is periodically lifted up by about 100 feet and dropped down as Io orbits Jupiter. The resulting heat melts sulfur present on Io, and it springs out like volcanic lava. Spectacularly violent tidal interactions can be seen when galaxies approach one another. Tidal force is an inescapable effect of gravity. The crowning moment for Newton's gravity came when planet Neptune was discovered. Neptune's position was precisely predicted by observing its gravitational effects on planet Uranus. Having glimpsed the effects of gravity on astronomical sizes and distances, let us now temporarily return to the gravity-related phenomena on the Earth. How would objects of different masses accelerate when falling under gravity alone? Here is Brian Cox, noted physicist, simultaneously releasing an iron sphere and a feather. Expectedly, the massive sphere lands first. Now, all the air in the chamber is being removed. The experiment is repeated. Now the feather and the massive sphere fall at the same rate at all times. A highly counterintuitive behavior indeed. That is, all falling bodies accelerate at the same rate. The great Galileo had indirectly inferred this profound idea by rolling spheres on an inclined plane. Gravity has had a profound effect on the lives and works of great minds as Galileo, Kepler, Newton, and so on. What about the effect of all-pervading gravity on life itself? The thin blanket of atmosphere hanging by gravity's thread offers the foremost protection from the harmful radiations coming from space. Pieces of rock from space hurtling towards the Earth mostly burn up in the atmosphere before they reach the ground and cause damage to living beings. Primitive or complex, small or big, terrestrial or aquatic, plant or animal, all forms of life are affected by gravity. The shoot and the root of a germinating seed grow and develop in different directions in response to gravity in order to carry out their respective functions. Seeds that disperse by wind have to dilute the effects of gravity to stay afloat in air for a long time, long enough to be carried far away from one another. This is essential to avoid competition for natural resources such as light and soil nutrients. And how well they achieve this. The tiny fungus here shoots spores that move faster than a bullet fired from a shotgun. Yes, faster than a bullet. The speed and the manner of our walking or running is also influenced by gravity. On the moon, under reduced gravity, it is difficult to walk at speeds like we do so on Earth. So astronauts on the moon find hopping to be easier than walking. In the evolving story of gravity, celestial motion once again plays a pivotal role. It was observed that the orbit of planet Mercury did not close on itself. Also, the farthest point in its orbit around the Sun gets gently shifted at the end of each revolution. Taking into account the effects of all the massive bodies in the solar system, Newton's law almost fully accounted for the observed shift. Almost. But not fully. Newton's gravity that had remained unchanged for 2.5 centuries was due for a revolutionary change to explain this discrepancy. We shall take a look at the new idea of gravity and how it completely explained the anomaly observed in Mercury's orbit. The seed for this new idea was sown in the year 1907 when Albert Einstein came to this profound realization. The happiest thought of his life, that a person falling freely experiences weightlessness. Well, if some of you are wondering if this is the shortest way to lose one's weight, please hold on. Conditions apply. You will regain all of it once you land. On a serious note,
प्लानिटोरियम बैंगलोर में शो हुआ था अंदर अभी पूरा. दरगाह हज़रत अब्बास अलैहिस्सलाम बैंगलोर. अस्करी बेंगलोर। रोज़ा जनाब सकीना सलामुल्लाह बेंगलोर। रोज़ा हज़रत अब्बास अलैहिस्सलाम आउटसाइड व्यू मस्जिद अस्करी।